Hi, I am Mohammed Shamim. Today I will present the Amazon SageMaker and briefly introduce some of its rich ML features using a case study. SageMaker is a fully managed machine learning service from Amazon. It helps us to easily develop and train machine learning models and deploy them at scale. It provides the SageMaker Studio, which is an integrated machine learning environment and hosts multiple tools such as Data Wrangler Autopilot. SageMaker offers common ML algorithms out of the box. Analyzing and responding to network logs can be often inefficient, costly, as well as prone to human errors. With the help of ML, a model can be developed that automates the analysis and responses to network logs. The use case considered is from network log firewall logs from University of California ML repository. There are 12 different features in total. Column action was considered as the target variable, which was a multi-class problem where expected outcomes are allow, deny, drop, or reset both. To start off, the dataset that was downloaded from the university website needs to be loaded into the Amazon AWS S3 so that we can use the data for the machine learning in the cloud. Amazon S3 is a web-based object storage service that you can use to store and retrieve any amount of data at scale from anywhere securely over the internet. You can search for S3 here and you can click on it to access the bucket console. And click on create bucket here. You can name your bucket and you can select the region that you need and you can click on create bucket at the bottom. The name that you give for your bucket should be unique. Once the bucket is created, you can enter into the bucket. Then you can upload the file that you need to use for your machine learning project. You can click on add files. You can choose your file that you need. You can click on open and upload. Yeah, so we have the file uploaded. Next, we will do a demo of the Amazon SageMaker notebook instances for machine learning model development using the data that we just uploaded. Amazon SageMaker notebook instance is a fully managed machine learning compute instance. Jupyter notebooks are used to develop and test ML models. From the management console, search for Amazon SageMaker here. You can see Amazon SageMaker, you can click on it. You will be inside the SageMaker console. On the left hand panel, you can see under notebook, there is notebook instances. You can click there. Then you can click on notebook instance creation. Here you can give a name. I'll keep the notebook instance type as well as the elastic inference as default. In the permissions and the encryption section for an IAM role, choose create a new role. So, create a new role. Once you select here, you can select the S3 bucket that you need to access, or you can keep it as any S3 bucket. Click on create role. Created. You can come to the bottom and you can create notebook instance. It will create the notebook. Yeah, once the notebook instance has been created successfully, you can click on Open Jupyter environment, and here on the right hand side you can click on New, come down and you can select by conda underscore Python 3. Yeah, here we have the notebook. Now we will make use of the notebook instance to build a classification model for the data set we have downloaded, or in fact uploaded to the S3 bucket. Here we can see that all the required libraries are imported for the notebook. We also import the Boto3. Boto3 is a Python library designed to help users perform actions on AWS programmatically. It will facilitate the connection between the SageMaker notebook and S3 bucket. Further, we define the bucket name that we defined earlier and the file name, and define the role and define the data location and read the data into a pandas data frame. Then we'll review through the data frame. We can see that there are 12 features in the dataset. The column action will be considered as the target variables, and the other columns will be considered as the features. The column action has 4 classes: allow, deny, drop, and reset both. We also go through the information of the data types. We see most of them are integer type and the action column is of type object. We'll also go through the count of the action column, the different classes. We see there is a visible imbalance between the label classes. The allow class has bulk of the data points, whereas reset both has very little data points. We will address this later in the notebook using a feature called SMOT. We're just reconfirming if there are any null values in the data set. Further, we do a little bit of feature engineering, where we convert the action column into values that can be understood by the machine learning algorithm. Here, the action column is converted as using factorize. Uh, we reconfirm whether the values, the counts are the same after factorize. The values are 0, 1, 2, and 3 right now, instead of allow, deny, reset both, and drop. Similarly, the columns as source, destination port, NAT source port, and NAT destination port are also they are ordinal numbers. They are not continuous, so we use ordinal encoder to convert them. Then we split the data set into test, train, and validations. We then split the predictor and response variables for all the data sets. Then we start off building a basic random forest classifier model and verify its accuracy. We also generate the confusion matrix. Then, as we saw, there is imbalance in the target variable classes. To address that, one method is to address those imbalanced classification in a decision tree is to change the weight that each class has when identifying the split point based on the impurity score. We can do that by using class weights within the random forest classifier, and we see the accuracy has little bit improved. The confusion matrix still shows there are misclassifications. This is there is something called precision and recall, which we kind of use. Which are, these are metrics that are used to evaluate a classification model. They are measured on the validation or the test data sets. In this table, the precision measures the correct predictions over the overall prediction in the classes. It indicates how good the model is at predicting this class. Recall, on the other hand, measures how correctly the actual elements in the class were predicted within that class by the model. So we can see here the class 3 has misclassified. The recall is not very good. We use SMOT to address this. The SMOT is synthetic minority oversampling technique, which where new examples can be synthesized from the existing examples of the minority class. So we make them almost equal by resampling the minority class. We convert them, and we made here all the classes of similar count. We generate the classification report. We see the precision and recall values. We can see that there is improvement in the recall. More minority classes were predicted accurately. Then we move on to the feature importance. We can see that destination port, elapsed time, bytes, and byte sent is having more importance in predicting the action. Then I used grid search to find the best parameters in terms of hyperparameters tuning. I converted as a markdown cell, as it takes a lot of time to run this code. The best parameters are here, and I use those best parameters into the random forest classifier. I predicted on the test set. The recall was markedly better. As you can see here, much more minority class predicted accurately. This is the classification report. The area under the curve for each of the classes of the test set. These are the ROC curves for each of the classes, which shows much better here. And here we have the predicted action put against the test set. As you can see here, and these are all the accuracies I got for each of the models I ran in this. Next, we move on to the SageMaker Autopilot. SageMaker Autopilot allows you to automatically build, train and identify the best machine learning models based on the data provided. To access the SageMaker Autopilot, you come to the SageMaker dashboard and click on Open SageMaker Studio. You need to create a user. You can you give a username and click on Submit, and then click on Open Studio next to the user. Once you are inside the SageMaker Studio, you can go to File, New, Experiment. Then you'll get the screen where you can enter your experiment name, you can select your S3 bucket name, your file, and you specify the target column, and then press on Create Experiment. It will run the experiments on multiple models and provide you with the best model. This was run earlier as it takes a lot of time, and I have the best model here. As you can see, it's very easy to run multiple experiments and get the best models. You can right click on the best model and go into Open New Model Details, and you can get the details of the model. You can see that the algorithm used was XGBoost. The feature relative importance you can see here. The elapsed time is the best feature. You can come down and you can see the metrics accuracy and the error values for the model, and you can see the max depth and other parameters such as gamma, lambda, etc. So that was fairly straightforward. Now we can come back to the best model. You can select the best model and click on deploy model. You can get the screen where you can enter the SageMaker, the endpoint name, the instance type, instance count. You can select save prediction requests and responses, and you can click on deploy model, wherein you'll get the endpoint status as you can see it as enabled, and data capture state is started. So with using this, now you can start giving new data to be predicted by this model. Next, we move on to the SageMaker Data Wrangler under the Studio. Data Wrangler is a GUI-based tool which simplifies and makes efficient the data preparation and feature engineering processes for ML. It reduces the time spent on these processes from weeks to few minutes and has more than 300 built-in data transformations. It has built-in visualization templates too. So what we do is we go to File, we go to New, and click on Flow. Here we see that there are multiple data sources we can select from, S3, Athena, or maybe other data sources such as Redshift. Click on S3. You can select your data source, select your file, and import. Then you can see the flow already starting up. You can click on this. You can edit data types. You'll find all the data types on the screen. On the screen, you'll find the different columns and its data types. As you can see, if you want, you can change them here. You can go back. Next, we can add some data transformation. Click on Add Transform. You can see the data here. You can also apply any kind of transformation. There are built-in transformation as well as custom transformation. For instance, the source port is a ordinal number. You can go to encode ordinal. You can select ordinal encode. You have uncode encode as well. You select an ordinal encode. You select the source port here, and enc underscore source port, and then you can preview and you can add it. Yeah, as you can see, you have the new column added. You can also remove the columns that are now, because you will have now two columns. You can remove those columns that are drop columns. You can select the column, source port. You can preview it, and you can add it. So now you will not have the source port column in the data file. Let's go. Next, you can run some analysis on the data. You can click here, add analysis. You have multiple options here. You can select histogram, for instance. You can give it a name. You can select the x-axis, for instance, action. Let's say destination port, and let's click on preview. There you have the histogram for the data that we selected. We can also do a quick model for if required. We can give it a name, for instance, quick model. You select the action as the label and click on preview. as you can see that the model has produced the quick model with the variable importance, as you can see here. So you have multiple options. You can do even scatter plots, etc. Let's go back to the flow. After doing all this, we can also go to export. We can select the transformations that you want to export, and you can go to, there are multiple export steps, such as save to S3, pipeline, Python code, or after exporting, you can use this in your own code or in your own projects, that wherever you need to use it. To summarize, the advantages of using SageMaker are its easy to use GUI interface, good supporting documentations, many built-in algorithms, ability to develop ML models with little coding experience. Some drawbacks are that the ML model development is built by the second while they are running, and the costs can spiral up. Docker containers will be required for models using third-party libraries. Thank you for your time.